and we shall go to our problem of the day. This week, a little geometry oriented. A trapezoid has a height of 12 meters, and its bases are 20 and 14 meters. What is the area of the trapezoid? Wow, it's a mouthful, isn't it? A trapezoid has a height of 12 meters, and its bases are 20 and 14 meters. What is the area of the trapezoid? Well, let's take a look at this thing, analyze this problem, and see how easy it is. Oh man, picture does make a difference, doesn't it? To have a picture, some of you are going like, I wonder what a trapezoid is. That's what it looks like somewhat. Now, it doesn't always have to look like that. These just kind of lucked out and gave us congruent pieces right here. However, one thing that is always true about your trapezoid, there will always be a parallel situation there. That's parallel bases, all right? And that's your base 1, we'll call it B1, and our second base, B2. Now, that's not squaring, that's just simply first and second base. Now, you say, well, Ernie, where's the height? Because we've talked about bases here. We'll put some numbers on there in just a second. We're talking about height. Where in the world is the height? Well, the height has to come down from a vertex, or basically any point on the parallel base up here. We'll pick a point, and we're going to drop straight down, making a nice right angle there. That makes a height, okay? That's what we're talking about. These are not heights. These are just legs of the trapezoid. We call them legs, all right? They have different measurement. But the numbers that we're looking for here, this, as I said, that little vertical segment will be our height. Basically, it's going from base to base, making actually a right angle with both bases, all right? That's the idea. That's the idea. How long is it? However far it is between those. In this case, it's going to be 12. Now, let's point out something else to you. The base measures, I'm going to go with the first base up here as being 14, and the bottom one here is 20 because the bottom's a little bit longer, all right? So, very simple, straightforward. We've got our numbers where we want it. Now, what we want to do is find out all the yellow space inside this trapezoid. All the yellow space inside this trapezoid. Now, by the way, let me just go ahead and point out something to you. We could have gotten my finger in the way there. We could have had a trapezoid with a right angle situation right here for one of the legs, all right? And then this side would tail off over here. That's another thing just to be careful about. It would be still a trapezoid because the definition of a trapezoid is exactly one pair of opposite sides running parallel. If you get two pairs of opposite sides running parallel, you're at a parallelogram. And it's a whole different ball game, all right? But we can cut off this little triangle here and still perhaps have 14 and 20 running out here and then a 12 going up vertically. So understand it's all about right angles. Right angles is to find the height. Now you say, Ernie, what does that have to do with the area? Everything to do with the area. Everything, because our formula for a trapezoid, area of a trapezoid is equal to 1/2 the height times the sum of the bases. 1/2 times the height times the sum of your bases, all right? And my friends, it's a formula. You know, people ask, what do you do with these formulas? Well, they're important because they tell us what to do with the numbers. So we're going to put the 1/2, going to leave it alone, but I'm going to put a 12 right in there. And on top of that, we're going to take 14 and we're going to add 20 to that, all right? So it's pretty straightforward. By the way, these are what we call variables. They stand for numbers, folks, in the world of algebra and arithmetic and computations and formulas. They are variables, and you supply the numbers for them to be able to work, all right? You've got to know what they are, otherwise you can't get to the area. Makes sense? You got to have all three of these numbers filled in. So let's see what happens. 1/2 of 12, oh, that was easy. We can do that as 6. Hey, what do we want to do with this 14 plus 20? We want to add them together, all right? So you've got some things going on here. Let's do order of operations because what have we always been told? Do the parentheses first. Do the parentheses first. So go ahead and add 14 and 20. And it looks to me like you're going to have 1/2 times 12. And you're going to get 34 out here. Now everything's multiplication at this point because you've taken care of the addition, all right, inside the parentheses. So we're going to look at, we're going to left to right, all right? And I can take 1/2 of 12, which gives me 6. Multiply that times 34. My goodness, what do we got out there, folks? I think it's going to be 204. And by the way, it's not meters, but it is square meters. And that's our area formula. Let's take a quick look on the calculator, see if it agrees with me, all right? Do a quick shot there. I'm going to take the formula. It says we're going to take 1/2. And by the way, I want you to notice the calculator knows how to do order of operations also. We're going to say 1/2 times, what was it, 12? And then we're going to multiply it times that parenthesis. We're going to put it in parenthesis, all right? That we had 14 plus 20. We'll close our parenthesis. And let's see if it gives me what I want. 204. It does. All right. Yes, your calculator does know the order of operations. And I tell you, these order of operation problems is so funny. You read about them on the internet. It throws people all off. You basically are working left to right, multiplying and division, get equal precedent, as does adding and subtracting. But always go parentheses first in a problem like this. Then just work it left to right. Okay? Hey, it's a great start for our week here. Our problem of the day.